In this video, I will explain the concept of indifference curves in economics. So consider the following scenario. Let's say I come up to you and I say, hey, would you rather eat 10 hot dogs per week and 1 burger per week? Or would you rather eat 6 hot dogs per week and 2 burgers per week? And suppose that you say, well, either of those choices sound good to me. I'm indifferent. They both would give me the same level of satisfaction. And then suppose I say, okay, well, what about this combination? What about 4 hot dogs per week and 3 burgers per week? And let's assume again that you say, well, I'm indifferent. That combination also sounds equally good. So all 3 of these combinations sound equally good to me. And then what if I say, okay, what about one more combination? And let's say, okay, what about 3 hot dogs per week and 6 burgers per week? And again, assume you say, well, that also sounds equally good to me as all of these other choices. So in other words, you are indifferent. All of these combinations of consumption sound equally good. Or in other words, you are indifferent to which combination you select. If this is the case, then what we can do is we can use these 2 goods, hot dogs and burgers, to draw something known as an indifference curve. So this is a curve on a graph that represents every combination of 2 goods that gives you the same level of satisfaction, or in economics we say utility. So on this graph, I placed hot dogs per week on the y-axis and the number of burgers per week on the x-axis. So as we mentioned earlier, we said that 10 hot dogs per week and 1 burger per week, so this combination right here, this gives you the same level of satisfaction or utility as 6 hot dogs per week and 2 burgers per week, so this point right here. And that gives you the same level of utility as 4 hot dogs per week and 3 burgers per week, so this point. And similarly, the combination of 3 hot dogs per week, but 6 burgers per week, so this point right here also gives you the same level of utility. So every point along this indifference curve gives you the same level of utility. Or in other words, you are indifferent to any combination of goods on this indifference curve. Every combination is the same to you. But now consider the scenario where instead of offering you, let's say, 6 hot dogs per week and 2 burgers per week, let's say I offered you 6 hot dogs per week, but 3 burgers per week. So that point would be out here. In economics, we usually assume that a greater quantity of some good gives you more utility. So you would prefer the combination of 6 hot dogs per week and 3 burgers per week to the combination of 6 hot dogs and 2 burgers. So what we'll find is that every point to the right of the indifference curve is preferable to every point on the indifference curve. And you can also imagine the scenario where instead of 4 hot dogs per week and 3 burgers per week, so this point, what if I offered you an additional burger, so 4 hot dogs and 4 burgers? That would be the point out here. Well, this point is obviously preferable to this point because you get more burgers with the same level of hot dogs. And what you can imagine we can do is construct another indifference curve that's to the right or further from the origin than the existing indifference curve. And you can imagine that we can do this over and over and over, so we can construct an infinite number of indifference curves in which every indifference curve that is further away from the origin, so every indifference curve that's going out this way, every point on these indifference curves is preferable to every point on an indifference curve that's closer to the origin. When we construct a bunch of indifference curves like this, we call that an indifference map. Now, when we have an indifference curve like this, the slope of the indifference curve represents the marginal rate of substitution. And what it tells us is the rate that we're willing to give up the good on the y-axis to get 1 additional unit of the good on the x-axis. So for example, consider the combination of 10 hot dogs per week and 1 burger per week. If we wanted to gain 1 extra burger per week, how many hot dogs are we willing to give up? So in other words, if we move from this point on the indifference curve down to this point, what is the marginal rate of substitution? Well, the way that we figure that out is we want to find the slope of this line, which we can estimate as the change in the y over the change in the x. So we would say the marginal rate of substitution is the change in the y, so this little triangle represents change, divided by the change in the x. So we can see what's the change in the y? Well, we're going from 10 to 6, so we're losing 4 hot dogs. So in other words, our y is changing by -4, and the change in our x is we can see we're gaining 1 additional burger per week. So we're going from 1 burger to 2 burgers. So the change in x is just 1. So our marginal rate of substitution is -4 divided by 1, which is just -4. And what this tells us is that at this point on the indifference curve, we're willing to give up 4 hot dogs per week just to gain 1 burger per week. And what's interesting is that if we repeat this process, so let's say now we're at this combination of 6 hot dogs per week and 2 burgers per week, now what are we willing to give up to get an additional burger per week? So moving from this point on the indifference curve to this point, our marginal rate of substitution is the change in the y is we're going down by 2 units, and the change in the x, we're increasing by 1 unit. So that's -2 over 1, which is just -2. So now at this point on the indifference curve, we're willing to give up only 2 hot dogs to gain 1 extra burger. And if we continue this process once again, so let's say we're at this point on the indifference curve and we're moving down to this point, the change in the y is -1. So we're losing 1 hot dog, but we're gaining 3 burgers. So our marginal rate of substitution at this point is -1/3. So we're only willing to give up 1/3 of a hot dog to gain 1 additional burger. So what we'll notice is that the slope of our indifference curve is getting flatter and flatter, and the marginal rate of substitution is approaching 0. So why is that? Well, to really understand it, consider the point up here where we have 10 hot dogs per week and 1 burger per week. We have a lot of hot dogs, but very few burgers. So to gain 1 additional burger, we're willing to give up quite a few hot dogs. So we said we're willing to give up 4 hot dogs just to get 1 extra burger. But then as we move down the indifference curve, so let's consider this point right here where we have 4 hot dogs per week and 3 burgers per week, we're only willing to give up 1/3 of a hot dog to gain an additional burger. And that's because we don't have as many hot dogs to give up now. So as one good becomes scarcer, we're less willing to give up that good to get an additional unit of another good. So that's why the slope of this indifference curve is getting flatter and flatter. So that was just a quick introduction to indifference curves along with their relationship to the marginal rate of substitution.